Hello everybody, this is a video tutorial about Agileto software tool. More precisely, we are going to discuss today about how to process Nemo Drive Test log file, extension NMF, in such a way that we can process and post-process everything with Agileto software tool. For this reason, we are going to open Agileto. And I want to remember you that there is a specific format that we need to use in order to do the drive test post-processing. So this is a kind of format for each technology. We have here the 2G technology, and we have some headers that need to be respected in order to be able to be accepted by Agileto. So in order to transform all of the drive test log file collected by Nemo in such a format, there is an option, there is a specific module that we are going to use today, and this is a module M4.3. So we select the section 4 and we use this module 4.3 to process drive test log files, Nemo or temps or something similar. Today we are going to concentrate on a Nemo drive test log file. So if we continue here, we continue by pressing OK, and in this dedicated window we can see that we have two options. One is for Nemo, the NMF extension, and another one is for temps. Today we are going to discuss about Nemo, how to transform and how to process these drive test log files. So for this reason we are going to take, for example, go to the place where the drive test log files are. We have already put some files together, and as you can see there are several files in the same folder, and here there is a warning saying that all the files from the same directory will be processed together. So in this case pay attention when you do, because you are going just to select a single file, and all of them, all the others from the same folder will be processed together simultaneously. So it doesn't matter which one you select from this folder, all of them will be processed together. So just select one of them, and here we have the warning that saying that all the Nemo files detected into the same folder will be processed together. Okay. After we have selected one of them, we just press OK button, and we see the evolution of the data processing of the files. Now we are on the second file, because three of them we have seen on the same folder, and we see each one which is the evolution, the progress evolution of processing each file. Okay, once everything is finished, we have here the results. The results, we will see they will be stored, dedicated files stored on the same place from where the original NMF file have been stored. And we can see here how many 2G files for the mobile and the scanner, the same for the 3G technology and the same for the 4G technology. Saying OK, and now we are going to see here near the other original data file NMF, we see the results. The results are going to be constructed by the name of the directory dt demo Nemo, followed by some syntax. For example, the first one is the GPS data, and if you open it, you can see very simple. It's the timestamp and latitude longitude of the drive test. It's very simple, maybe to plot to see where the drive tests have been placed. then we can see there is a series of data where we can have something like M2G, means the mobile on 2G technology, M3G means mobile in 3G technology, and then we jump for S2G, means scanner in 2G technology, and then scanner 3G technology, scanner 4G technology. The last part is the frequency band where the data have been subtracted. In this case, for example, we have a mobile 2G in 900 megahertz band. Here it's a DCS 1800 megahertz band for the 2G technology, and here it's they are all together mobile 2G technology, but all of the frequency bands together. Here we have the same for each 3G frequency layer. From the mobile we have different layers. This represents the downlink UMTS absolute radio frequency number 3011, 3075, 10,564, and so on. Then we start with the scanner for the 2G technology in 900 megahertz band. This is convention. This is a scanner 2G in 1800 megahertz band. And here are all together from the scanner point of view. Then we have the data collected from the scanner in 3G technology on this downlink UMTS absolute radio frequency channel number. So this is the same is for the scanner in 4G technology, where we have this evolve absolute radio frequency channel numbers 2825, respectively 6300. So if you want to see how it looks like inside, we need to recall a bit how looks the help file, and we can see that we have for each technology two ways to present the data. The first one is topics in line format, so top 1, top X servers, which follow a specific format, but the data are in line. The second part, it's here, it's topics different line format, and in this case we have for the same each line represented information, and for another top 1, top 2, top 3 there is a dedicated line where the timestamp is repeated for the same point, acquisition point. Of course, the GPS information, latitude and longitude, is repeated. Only what is varying, what is changing, it's there are the value from the topics server. In our case, top 1 absolute radio frequency channel number, RSSI, and BSIG for the 2G technology. Now if we return and we come back here, for example, to see what happened with this data, we can see very easy that if we just format a bit to be more clear what is really timestamp, I will just put more decimal to be able to see properly the timestamp. Yeah, and we can see, for example, for this timestamp, which is the same, we have different value, different servers. From the first one, which is with a very high level of dBm, the power here it's RSSI, and the last column it's the BSIG. Doesn't matter that we do not have BSIG decoded in different lines, because the software Agileto is going to work and to take the best cell which is detected with this BCCH around this latitude and longitude. So this is a format that we are going to use now, and as you can see, everything is already now. We have here, let's say, the second timestamp, where we have different value from the top 1 to top X, best server, and so on. So this is practically the information in 900 megahertz band with the data coming from a mobile in 2G technology. It is very fast. You don't need to do anything else. The same is for another frequency band, but here, of course, the absolute radio frequency channel number, they are going to range on different intervals, because it's DCS 1800 megahertz. So the BCCAG values or absolute radio frequency channel numbers are different, and so on. This is for 2G. For the 3G, we are going to have let's say the same part for the timestamp here. We just do once again the customization for the timestamp, just to be sure that we receive the good format, and we see here the milliseconds at the end, and we have some data where GPS is missing, for example here, and the headers are the same like presented here in into the file, data file. But for the 3G, here we have top 1 scrambling code, top 1 CPH ECNO, and top 1 CPH RSAP. So in different line format, we have the results just presented here. And this is the data coming from a mobile in 3G technology, while he was working on this downlink UMTS absolute radio frequency channel number 3011. Similarly are the results for other frequency. Here you can see different other frequency. Now we have as well a possibility to get the scanner values. If we have involved scanner during the drive test measurements, Agileto is going to extract separately the information from the scanner. For example, here we have the scanner in 900 megahertz band. The format is quite similar like the one that we already presented before. It's with already predefined header strings necessary to be imported and recognized by Agileto, so you don't need to do anything else. You just we just browse them a bit in order to be sure that everything was processed properly. So this is for the scanner from the 2G. The same is for the scanner from 3G technology on this frequency layer. 3075, it's the downlink UMTS absolute radio frequency channel number, but the headers are exactly the same, so already prepared with the timestamp, latitude, longitude, and then the scrambling code, CPH ECNO, and CPH RSAP for the top 1, top X best servers, line after line. So everything is clear, and now we are going just to discuss the last part for the scanner in 4G technology. Here it's exactly the same principle. The only thing that we are going to present is the header. The header is going to be the header from which is understood by Agileto in different line formats, like you can see here: top 1 PCI, top 1 RSRP, and top 1 RSRQ. So exactly the same format we have here. So we just need to use this file already prepared, and then we can process everything during let's say a common activity. And for this reason I will just take, for example, one file as an input, and we will see that Agileto is recognizing it. Like, for example, I will take let's say this file to process like an input by the module special module 4.1 based on the drive test, and we put as an input let's say, doesn't matter which one we select, this one, and we see here it's already recognized to be like a 3G intrafrequency. And if we go forward, if we pass this part of the neighbors, we see here that we need now to select here which is a frequency layer, for example, according with the frequency that was selected and mentioned here in the name of the file, 3075. We need to put 1, 2, 3 or 7 according with which layer that it does belong. And of course after that you need to data fill here the latitude, the correspondence longitude, the timestamp, and here after that the spatial binning that you want to apply, 5 meters and so on. All the others are related to the module 4.1, but what I wanted to show you, it's this is a way how you can process very fast Nemo drive test log file, original Nemo, and convert them in the top 1 top 6 best server in order to be easy accepted by Agileto. Okay, so hopefully the lesson from today was clear. If you have any question, do not hesitate to send us your feedback by email at agileto around support.com. Thank you for watching, and bye for now.